Hello everyone, welcome back to my channel Tamil Quality Inspection. Today we are going to discuss about the topic on carbon equivalent value. So some of the subscriber they don't know Tamil, so I want to explain in English. From now, from now onwards, I'm going to put a video both in Tamil and English. So let's we get started. I hope everyone hear that terms carbon equivalent value in metallurgy. So this carbon equivalent value is a parameter used in metallurgy to quantify the combined effect of carbon and alloying element. So to calculate the carbon equivalent value, we should know the percentage of the carbon and alloying element. So here the alloying element is nothing but manganese, nickel, chromium, and etc. So this alloying element will add along with carbon to improve the properties. So this carbon equivalent value it will directly affect the weldability and hardness of the steel and other alloys. This carbon equivalent value is a critical factor in understanding how the different material behave during the process, like welding, heat treatment, and cooling. With the carbon equivalent value, we can estimate the response of the material to the welding process, especially in terms of risk of cracking in the adjacent zone and formation of brittle microstructure. This carbon equivalent value directly affect the vulnerability of the material and causes the risk of cracking in that case zone. How the carbon equivalent value influence the material? First, it will affect the vulnerability. If the carbon equivalent value is higher, specifically in the steel, it is more prone to cracking during the welding. So we can face cracking issues during the welding because of carbon equivalent value. The more carbon and the allying pressures, it will increase the harder that hardness of the material and reduce the ductile properties of the material and become more risk of cracking, especially in the I'd say is the zone during the welding process. If the carbon equivalent value is high, the material will be more harder and lower in toughness. Even though the material exhibit good strength because of hardness, it may be more susceptible to failure under impact and stress because of higher hardness. It can break, it can fail due to higher hardness. Then next thing is a cracking resistance. If the carbon equivalent value is higher in the material, there's a greater risk of cold cracking after the welding. So to avoid these issues, Preheating, control cooling, and post-well heat treatment is necessary. Then the heat treatment required. If the carbon equivalent value is more, we have to determine appropriate heat treatment process, and it may require adjustment in the process to avoid unwanted microstructural changes. And you know how the carbon equivalent value it's affects the material. These are the factors is directly affect the material. You are seeing this formula. This is for carbon equivalent formula. Ce equal to C plus Mn divided by 6 plus Cr plus Mo plus V divided by 5 plus Ni plus Cu divided by 15. C for carbon, Mn for manganese, Cr for chromium, Mo for molybdenum, V for vanadium, Na for nickel, C for copper. So you have to include all the values in percent, and you will get the carbon equivalent value. Based on the carbon equivalent value, you can guess the properties and their response during the welding. So you can see how the carbon equivalent value influence during the welding based on the values. First, if the carbon equivalent value is low, the value is lesser than zero point 0.4, these type of steel it can be easier for welding, and it will not prone to cracking. It will resist to cracking. And second is medium carbon equivalent value. The value is in between zero point 0.4 to zero point 0.6. This type of steel may require more controlled heating, like preheating and controlled cooling to avoid cracking. Maybe it, it is susceptible to cracking. So for that we have to do proper preheating or controlled cooling during the welding process. And at last, high higher carbon equivalent values. If the value is more than zero point 0.6, this type of steel is more difficult to weld and have a higher risk of cracking. So to avoid risk of cracking, we have to give more precautions by proper way of preheating, in the post temperature control, and post well heat treatment is required to avoid risk of cracking. This is about carbon equivalent values. I hope you understood the topics. If you like this video, put the like button, subscribe and share. We'll see you on next topic. Goodbye. Take care.